So in example 2, we're going to use that same strategy. Our plan is to get both sides as a single power with the same base. Because if both sides are a single power with the same base, then their exponents must be equal as well. So in A here, we look at the numbers. We've got 2 to the x, we've got an 8, we've got a cube root of 2. And if I look at the numbers and think of my powers chart, can you see that 8 is on your powers chart with a base of 2? 8 is 2 cubed. So I can change the 8 to 2 cubed. Next, I have the cube root of 2. And this is something from grade 10 and 11, pre-calculus. Do you remember that you can change a square root, cube root, to a fractional exponent? So maybe at the top here, just to remind yourself, square root of x is the same as x to the half. The cube root of x is the same as x to the third. Maybe do one more. The fourth root of x is x to the 1/4. So I could change the cube root of 2 to 2 to the 1/3. I have a single power on the left, but on the right-hand side, I'm multiplying 2 powers with the same base. Do you remember that exponent rule? What would you do if you had x squared times x to the 4? You would get x to the 6. If you're multiplying with the same base, you add the exponents together. That's true even if they're fractions. So this will be 2 to the x equals 2, and I can add those exponents. 3 plus 1/3. How do you add fractions? You need a common denominator. The 3 would be 9 over 3 plus 1 over 3 gives me 10 over 3. And now I'm at this point where I can go, I've got a single power on both sides, so x would equal 10 over 3. Part B is going to involve a lot of rules. First of all, we look at the numbers, 125 and 625. We go back to our powers chart and say, do those numbers ever appear in the same column? Yes. They're both powers of 5. So that means that I can, and I'm going to take my time on this one, I'm going to change 125 to 5 cubed and leave everything else the same. And I'm going to change 625 to 5 to the 4. Sometimes if we take our time, we make less mistakes. If we try to do too much at once, we make a few more mistakes. Next, I can change the square root to a half, and I can change the cube root to a third. And then we've got powers to powers to powers. So what happens when you have a power to a power? You multiply. So this side's really easy. 4 times 1/3. That's going to be 4/3. This side I'm going to do it in 2 steps. 3 times 1/2 will be 3 halves. And then 3 halves times 2x plus 1 . And we got to the stage where we have a single power here and a single power here. So we can go, so 3x plus 3/2 should equal 4/3. If I move the 3/2 over to the other side, how do you subtract fractions? You need a common denominator. This will be 8/6 minus 9/6. Gives me -1/6. Divide both sides by 3, which is the same as multiplying by 1/3. And we get x is equal to -1/18. So if we review what we've done so far, our goal is to get to the places where I have the things circled in green and blue. Our goal is to get both sides to have a single power with the same base. Because if we can do that, then the exponents have to be equal, and sometimes it's like you're done, but on the side with the blue, you still had to do a little bit of algebra to figure out what x is. How do we do that? Well, we need to remember our exponent rules. We're going to use our powers chart to get the base the same. That's sort of a first step. Let's get the bases the same with everything. And then we have all of our exponent rules to combine things to get a single power. So we were reminded of the exponent rule. When you multiply with the same bases, you can add the exponents. We saw if you have a power to a power, you can multiply. We also were reminded that you can change square roots and cube roots and fourth roots to exponents, and those can help us as well. I would like you to circle questions 9 and 10, and I'm actually going to give you 5 to 10 minutes right now to try this to practice.